AI, machine learning, deep learning, I mean, you hear these words thrown around everywhere, right? But what do they actually mean? How do they all fit together? Well, if you've ever felt a little lost in all the jargon, don't worry, we're going to break this down step by step and get a really clear picture of how these brainy machines actually work.
So here's our game plan. First, we'll hit the big picture, kind of like looking at the AI family tree. Then we'll dive into the 3 main recipes machines use to learn stuff. After that, and this is the cool part, we'll uncover the secret sauce that makes deep learning so incredibly powerful. We'll briefly touch on the tools that make it all happen, and we'll wrap it up with a super fast cheat sheet you can take with you.
All right, first up, the big picture. The goal here is pretty simple. We want to stop these terms from being just a confusing word soup and, actually arrange them in a way that makes sense, like a family tree.
This is the question, isn't it? The one that gets everyone. Are they all just the same thing? Are they different approaches competing with each other? Or is the relationship a lot simpler than that? Let's clear this up once and for all.
Okay, so let's start with artificial intelligence, or AI. You have to think of this as the giant, all-encompassing umbrella. It's the original dream, right? The grand ambition to make a machine do anything a human would consider smart. We're talking reasoning, planning, understanding language, the whole shebang. For our purposes, it's the biggest, outermost Russian doll. Now you open up that big AI doll, and what do you find inside? Machine learning. And here's the key. It's not a totally separate thing. It's a way to achieve AI. Instead of a programmer writing a million if-then rules, we just feed the machine a ton of data and let it figure out the patterns for itself. It's the engine that really brought modern AI to life. It's our second doll. And what's at the very center? You open the machine learning doll and you find deep learning. This is the rocket fuel. It's a supercharged, specialized type of machine learning that uses something called neural networks, which are loosely inspired by the human brain. So, to put it all together, AI is the overall goal, machine learning is a set of methods to get there, and deep learning is a really, really powerful technique inside of machine learning. Okay, so now we know that machine learning is all about learning from data. The next logical question is, how? Let's look at the 3 fundamental recipes for how that learning actually goes down. So the 2 most famous styles are supervised and unsupervised learning. Supervised learning is exactly like studying with flashcards. You show the machine a picture of a cat, and you tell it, hey, this is a cat. You give it the answers. Unsupervised learning is the complete opposite. It's like you dump a giant, messy pile of Legos on the floor and just say, go figure it out. The machine has to find its own patterns and maybe sort the bricks by color or shape or size, all on its own with 0 instructions. And this table here really lays out the trade-offs. Just look at that top row, data labels. Supervised needs all the data to be labeled, and if you jump down to key weakness, you see the problem. That's crazy expensive to do. On the other end, unsupervised needs no labels, which is cheap, but its weakness is that the patterns it finds can be really hard for us humans to make sense of. And that's where that middle column comes in, semi-supervised. It only needs some labeled data to help it understand a whole lot of unlabeled data. It's a super practical compromise. So yeah, that third way, semi-supervised learning, really tries to get the best of both worlds. It's like having a few flashcards to get you started and then a giant pile of Legos to practice on. Imagine you're a radiologist. You might have a few hundred x-rays you've personally analyzed. Those are your labeled flashcards. But you also have access to millions of anonymous x-rays. That's your giant pile of Legos. This method uses your expert knowledge on the small labeled batch to go find important patterns in the huge unlabeled one. It's just incredibly efficient.
Okay, now we're getting to the absolute heart of it. We know deep learning is a special type of machine learning, but what makes it so special? What was the big aha moment that basically kicked off the entire AI revolution we're living through right now?
Back in the old days of machine learning, and I'm not talking that long ago, it was all about manual labor. Seriously, if you wanted a machine to recognize a cat in a photo, a human expert had to sit down and literally write code to define what a cat is. They'd have to tell it, okay, look for pointy ears and whiskers and a specific fur texture. It was painstaking, and honestly, it didn't work that well. And then, deep learning completely flipped the script. The new way is all about automatic discovery. You don't tell the machine anything about whiskers or pointy ears. You just dump thousands and thousands of pictures labeled cat in front of it, and you let it figure out what the important defining features of a cat are all by itself. And this superpower has a name. It's called automatic feature extraction. It's the whole game changer. Those deep, multi-layered networks learn in stages. So the first layer might just learn to see basic edges or patches of color. The next layer might combine those edges into corners and textures. The layer after that combines those into shapes like an eye or a nose, until finally the top layer puts it all together and recognizes the entire concept of a cat. It builds that understanding from the ground up, with no human help.
This table right here, it basically sums up the entire revolution. Look at that first row. Feature engineering goes from manual to automatic. That is huge. And because of that, as the second row shows, deep learning needs way more data to really shine. Finally, the whole learning process changes. It goes from being these separate, clunky steps to one seamless, end-to-end process that goes straight from raw data, like pixels, to the final answer.
Of course, this whole revolution wasn't just about big ideas. You need the tools to actually build this stuff. So let's take a quick look at the software that made all of this possible.
For a long time, building AI meant you had to start from scratch. You were using these really complex toolkits, really only meant for PhDs. But the game has totally changed. Today, the focus is shifted. Now it's all about using these enormous, powerful models that have already been trained. The whole community is now built around these hubs that were kind of like an app store for AI, where any developer can go find a powerful pre-trained model and adapt it instead of having to build one from the ground up.
Whew! Okay, we have covered a lot of ground. So let's lock it all in with a quick start guide, a 30-second recap of the most important things to remember.
All right, here's your cheat sheet. If you remember anything, remember this. 1. The Russian dolls. AI is the big idea containing machine learning, which contains deep learning. 2. The 3 learning styles. Supervised is flashcards, unsupervised is Legos, and semi-supervised is a mix of both. 3. Deep learning's superpower is automatic feature extraction. It just figures things out on its own. 4. This is why it gets so much better the more data you feed it. And finally, number 5. The tools have changed. We've moved from building blocks to massive hubs like Hugging Face.
And that brings us to one last big question to think about. For decades, one of the most valuable human skills in this field was the expertise needed to tell a machine what features to look for. Now that machines can do that on their own, what do you think is the next great human skill that's going to be most valuable in this new world of AI?